Okay, I'm going to do a little quick tutorial here about annuities and the annuities formula. It's got the formula on the screen there. Sometimes the textbook has the formula slightly different. Right there where it's got an R, sometimes a textbook puts a PMT there. If you look what it is, R is the regular deposit or payment. So sometimes it's a PMT for payment in dollars, where before with our compound interest formula we had the end amount we're putting into a bond or something, an amount now, which was our P, our principal. This one doesn't have a P, it doesn't have a principal. What is happening at this one could be something where we're paying into something. So this is a regular payment that we have to make. Perhaps we, one time where I used kind of something like this was we bought a new roof and we had to make regular payments on this thing. So when you're setting this up and you want to figure out how much there's interest in on it, you're going to have to make so many deposits, and you want to see how much is this roof going to end up costing me. A whole bunch of money. So the A is still going to be the future amount or the end amount once you're done paying off this roof. The R or the PMT is our payment. I think this likes an R because it's one variable instead of three variables, where sometimes people think that they got to sub in three things. Anyway, I is still our interest rate, N is still our number of deposits. And again, it's our interest rate per compounding period here. So let's just, I'm going to set up a couple questions. So J deposits $1,500 every 3 months for 2 years into a savings account that earns 10% per year, compounded quarterly. Remember that quarterly comes into it. How much money will, I guess, he have accumulated at the end of 2 years? Okay, so we've got right from there, he deposits that much. There's our payment, 1,500 or 1,500. Okay, now this is where I was saying the quarterly was going to come into it. It's 10% compounded quarterly. So remember from before, we got to take our interest rate, divide that by 4. Okay, so 10% would be 0.1. I think we do that. It does it all in one step. 0.1 divided by 4. There we go. Now, for our number of payments here, J deposits every 3 months for 2 years into a savings account that earns how much at the end of 2 years, compounded quarterly. This N is the exact same as our number of compounding periods. So it's going to be in there for 2 years. It's going to be compounded quarterly. So whereas before we divided, and this is just something I always just remember, divide the N, or sorry, I totally messed that up. Divide the I times the N. Divide the I times the N by the compounding period. So our compounding period is 4 here, so that's why it's 4 and 4. A is what we're looking to do. So all we're doing is taking that formula, and even as you can see in other, even when you take this during the full year, during the final exam and on the test, you get a formula sheet. This is one of the formulas on the formula sheet. All you got to do is plug in exactly those numbers into your formula and then go about solving. And I think there was a typo in this slide here. So that is how much it ends up costing at the end of the 2 years. Okay, there was one example. I think that's taken right from the textbook. Another one, now this one's slightly different. If they don't give you, I think this one doesn't give you the payment. So in 25 years, they want to have $1 million. Her current investments are, so here comes our interest, 12% compounded annually. Compounded annually is nice. We don't have to do the divide and multiply thing. Annual is 1. So if I divide by 1 and multiply by 1, it's the same. So 12% is my percent. 25 years is my N. I don't know the payment. I know the end amount in this one. So if I'm looking at my formula, I know the A, but I don't know the R. So we might have to sub in and rearrange things here. So the first thing I would do is multiply both sides by 0.12. That's what they did there. Then I would solve what's in the brackets there. Oh, they divided it first. I would solve it, so you could always do 1.12 to the exponent 25, whatever that is, minus 1, and then divide both sides by that. They did it early, which is fine. You'd get the same thing, and you'd get something like that. Okay, that's about it. So, and the only difference between an annuity and the regular compound interest, for regular compound interest, it's like you're putting something into a bond or something. So if you have an extra $2,000 you're not going to need for 5 years, you put it into a bond, you put it in at the beginning, and you're getting interest on it, and then when you take it out, maybe you get $2,500. You get a free $500 just by leaving this in a bank account. So if you have lots of money sitting in your bank account that you're not touching, it makes sense to put it into a bond because you get some free money. This one is a little bit different where you're making a regular payment. So perhaps in these examples, you're saving for retirement or something like that. A lot of the times it happens the other way where you're paying something. But anyways, hopefully that helps and you can try some of those questions there.